class. You may be happy to learn that we are starting the final module of the course today. So I know it's been a rather long haul. In this module, we concentrate on the derivatives of trigonometric functions, as well as the natural logarithm and the exponential function. And we can refer to these functions as transcendental functions. So I would suggest definitely that you keep a copy of this formula page in front of you at all times when you're working on questions from this unit. These are formulas that you don't have to memorize, you just need to know how to use them. So they are numbered 1 through 8. The other things included on this sheet are some very common trigonometric identities. So the reciprocal functions for sine, cosine, and tangent, which are cosecant, secant, and cotangent. And also this fact here, that tangent is always equal to sine divided by cosine. And at the bottom of the page are the formulas from the first unit of this course, including the one that we used to take the derivative of polynomials, the derivative of x to the n. The chain rule is included, product rule, and also the quotient rule. Okay, so what we're going to concentrate on in this first video are these first two derivatives. The fact that when you differentiate sine, you get cosine, and when you differentiate cosine, you get negative sine. Notice that the angle is little u, and it remains little u. So the angle itself does not change. And also notice that after we have differentiated the function, we have to multiply by the derivative of little u itself. So we're multiplying here by du by dx, the derivative of the angle. Okay, so let's practice using these first two rules. I've got some examples here that I'd like to start with. So here we go. We have y equals 4 times the cosine of 6 pi theta squared plus pi over 4. So the independent variable here is theta. Okay, so unlike our rule sheet, which has an independent variable equal to x, in this first example, our independent variable is theta. Okay, so we're going to be using the second rule, the derivative of cos u. And it's important to note that this right here, this whole argument is our little u. So we're going to begin to form y prime. So the first thing we do is note that the derivative of cos u is negative sine u. So we're going to have negative 4 times the sine of, now we keep this angle exactly the same. Okay, so that is our little u still. So we've done this part, negative sine u. Now we need to multiply that by the derivative of u with respect to theta. Okay, so what is the derivative of this angle with respect to theta? Well, the derivative of theta squared will be 2 theta. So we end up here with 6 pi times 2 theta, or in other words, 12 pi theta. So this part here represents du by d theta. Okay, so now we've got all of the elements. We've got negative sine u times du by d theta. Of course, the derivative of this constant pi over 4 was 0. So that's why the full derivative of this is 12 pi theta plus 0. Okay, so now in writing the final answer, we can't change the trig function at all, but we can move 12 pi theta to the front where it'll multiply by negative 4, and that'll give us our final answer, which is negative 48 pi theta times the sine of 6 pi theta squared plus pi over 4. Just like that. Okay, so every time again there will be two elements. In this first case, the first element was negative sine u, and that's here. Multiplication by du by d theta. So the derivative of this argument, which is 12 pi theta. Okay, let's try another one. Now, in question 2, you can see we have this exponent placed here, sine cubed of sine cubed of 2x to the 4 plus 1. You need to know that that means the entire sine function is cubed. So we have this, 2 times the cube of the sine function. And that's what we're going to differentiate. And to do this, we're going to use the chain rule. So the first thing that happens, the 3 comes forward and multiplies by the 2 here. We will get 6. The inside of this bracket will not change, and the exponent is lowered by 1. Okay, so this is the beginning of the chain rule. Now we have to multiply by the derivative of the inside of this bracket. So we need the derivative of sine of 2x to the 4 plus 1. Well, its derivative will have 2 parts. The first part will be cosine of 2x to the 4 plus 1. That has to be multiplied by the derivative of 2x to the 4 plus 1. And its derivative is 8x cubed. Okay, so we're doing the chain rule. So first, 3 is multiplied by 2. This exponent is dropped down to a 2. In forming the derivative of the inside here, we're treating this part as the little u, the angle. So its derivative is cos u, so this again is the angle, times the derivative of u with respect to x. So this part here is the derivative of u with respect to x. Okay? All right. So now when we write out our final answer, again, we can't change the trigonometric parts, but we can bring 8x cubed forward. It'll multiply by the 6 to give you 48x cubed. Then we have the sine function all squared, which we might choose to write this way instead. And then we have the cosine function. Okay? And this can be at the end with this written in the second position. That would be the same thing, okay? But generally the algebraic part will be first, and then the order between these two parts could differ. All right, let's try another one. So question 3. Now look, in question 3, the independent variable now is little t. And it happens to be here and also here with multiplication in between. So this means what we actually have is a product. Now I'm going to use a capital U and a capital V, okay, for the product rule, just so it isn't confused with all of the little u's referring to the arguments here. All right, so let's work out first what we're going to use for u prime and what we're going to use for v prime. So u prime is the derivative of 6t squared, so that will just be 12t. Now, what will we use for the derivative of sine of 3 pi t? Well, its derivative will have two parts. The first part is cosine of 3 pi t. And that is multiplied by the derivative of 3 pi t. And the derivative of 3 pi t is 3 pi. So again, we're treating this as the little u in sine u. So its derivative is cos u times this part here is du, not by dx, but rather by dt, since little t is the independent variable in question 3. Okay, a more natural way to write this is with the 3 pi in front of the cosine term. Okay, so 3 pi times the cosine of 3 pi t. So that's what I'm going to use for my v prime. Okay, so the constant in front of the trig function. So now we can form y prime. Now we need the product rule, so uv prime plus vu prime. U times v prime plus v times u prime, like that. So this is 18 pi t squared cosine 3 pi t plus 12t sine 3 pi t. So that's just simplifying this term and simplifying this term. And now I should common factor. All we can do is compare 18 pi t squared with 12t. And both of those portions are divisible by 6t. So 6t can be removed as common. So when we divide this by 6t, we will get 3 pi t. When we divide 12t by 6t, we will get 2. So that's how the common factoring is handled. You cannot touch the trig functions at all. You can only common factor from the algebraic part here in front of each trig function. And so that is what we divide by 6t. Okay? Extra bracket floating around here, I guess. All right, so that is the third example. All right, since we just did a product, why don't we do a quotient? So capital U capital V, and now I'm going to do the derivative of each first. Okay, so what is the derivative of 2x plus 3? It is just 2. But what about the derivative of the sine of x squared? Now, look, in question 2, the cube was written here. Sine cubed of this angle. And it meant the whole sine function was cubed. That's not the case here. The little 2 is not written here. Okay, it is not written here. It is here. It is only the exponent on x. In other words, what we have sitting here is like a sine of little u. And little u is x squared. So that means the derivative of v is formed like this. The sine of x squared is the cosine of x squared times 2x. Cosine of little u times the derivative of little u. Okay, so that's little u. This part here is the derivative of little u. Okay, and again, we would normally write this with 2x in front of the cosine of x squared. All right, and now we can use our quotient rule. So how does the quotient rule go? Well, it's on the sheet, right, at the bottom. VU prime minus UV prime over V squared. Oopsie. V times U prime minus U times V prime over V squared. Okay, so there's not going to be a whole lot we can do here, but I think I will open up the bracket here, okay? And here we write the 2, of course, in front, constant in front. Okay, so now we're going to get minus, and the 2x will be multiplied by 2x cos x squared. So that's going to give us 4x squared, so negative 4x squared cos x squared. The next term is also negative, and it is 3 times this term will be negative 6x cos x squared. And the bottom we won't change. Oops, I went very crooked there. I'm sure that you don't mind too much. So the bottom we can leave exactly like that, or remember we can move the 2, this 2 here, and it means the same thing. Okay, the only thing I think we can do is maybe take 2 out in the numerator, leaving it like this. Okay, so that's if we divide all 3 of these coefficients by 2, then their coefficients are 1, -2, and -3 respectively. So I hope you understand the negative here gets distributed to both this term and this term. And again, when you're multiplying this by 2x, only the front part changes. The trig function does not change, okay? That's why we have 4x squared here and 6x here, both preceded by -1 factors. Okay, all right, let's continue to do a few more. So this one is a little bit strange. We have the cosine of the sine of 3 theta. So it's as though this is the little u on sine u. So let's get started on forming z prime. So we have cos little u. So its derivative will be negative sine of little u. So this becomes negative 0.2 sine of little u. Okay, so the little u angle stays the same. So negative sine little u times. Now we need the derivative of little u, but not with respect to x, but rather with respect to theta. So here now, we need the derivative of little u with respect to theta. Okay, so we had cos little u. It became negative sine of little u. And now we need the derivative of little u itself. But that means the derivative of sine 3 theta. What's the derivative of sine 3 theta? Well, it's cos 3 theta times 3. So all of that right there, those two parts, represent the derivative of sine 3 theta. Okay, so this is a little bit tricky because we have one trigonometric function nested inside another. In other words, the argument of cosine is a sine function. So this is sometimes called composition of functions. Okay, so when I go to write my final answer, the 3 can move forward and multiply by negative 0.2 to give us negative 0.6. And then we can follow either with this function next or this function next. So you could put cos 3 theta first, then sine of the sine of 3 theta. Or we could have put this one before this one and it would be the same thing. So this is a little bit tricky. Again, that's called composition of functions. I can write the word for you. Composition of functions. All right, we're going to do just 2 more together. So here's a 6th problem. Now we know that the square root sign is no good to us. So we would begin by making the exponent 1/2. And this doesn't require a quotient rule because there is no x in the numerator. This is just a constant. So the easier way to solve this is to bring this up with an exponent of negative 1/2. And now we would use the chain rule. Okay, so where else did we use the chain rule? Here, once we had this, right, with the outside external exponent here, we use the chain rule. Okay, number 3 was a product rule. Number 4 was a quotient rule. But yeah, the chain rule is when you have the whole function in the bracket with an external exponent, like number 2. So that's what we have here. So when we form y prime, the first thing that happens, the exponent, negative 1/2, comes forward and multiplies by the 2 here to give us negative 1. And then the inside of the bracket does not change. The new exponent is negative 1/2 minus 1, which is negative 3/2. And now that that exponent business is done, we have to multiply that by the derivative of the inside of the bracket. So we need the derivative of cosine 5x. So 5x is like the little u on our cosine u. So the derivative of cosine 5x is negative sine 5x times 5. Negative sine 5x times 5. So all of this is the derivative of cos 5x. This is the little u, and this is gu by dx. Okay? So the derivative of cos u, negative sine u, times du by dx. Okay, preparing our final answer, we have -1 times -1 times 5, so that's positive 5. We should bring this to the denominator where the exponent can be positive. So in the numerator, we'll have 5 sine 5x, and underneath it, we'll have cos 5x to the positive 3/2, like that. And we might as well go back to radical form, since that's the form the question started with. So it becomes the square root. The denominator here is the index. And when it's square root, the 2 is implied. We don't need to write a 2. And now we have cosine 5x all cubed down here, which we might prefer to write like this, cosine cubed of 5x. But you don't have to. You could write cosine 5x in a bracket with a cube outside of the bracket, and that would be the same. Okay? So that's number 6. Let's do one more for now, and then it'll be time for you to practice some, okay? Okay, so we're going to try this question. 5t minus 25 cos squared of 120 pi t. Now, 2 different terms. So all we do is take the derivative of the first term, and then from it we subtract the derivative of the second term. But before we begin, we should rewrite this. What is squared here? Not the 25, but actually round bracket would be fine here. So there's only going to be the one bracket. So not the 25, but the whole cosine function is squared. Okay, so that's just rewriting the original function y. Cosine 120 pi t is what is squared. So now we can do y prime. What's the derivative of 5t with respect to t? Just 5. Minus, and now look, this part right here, this is going to require the chain rule. So not for this term, but for this term here, we're going to use the chain rule. So how is that done? The 2 comes forward and multiplies by the 25. The inside of the bracket does not change. The new exponent is 1 less than 2, so it's a 1. And then we have to multiply that by the derivative of the inside of the bracket. So what's the derivative of cosine 120 pi t? Well, this 120 pi t is like our little u. So what's the derivative of cos u? Negative sine of u negative sine of u times the derivative of little u with respect to t. What's the derivative of 120 times pi times t? It's just 120 pi times 1. So it's 120 pi. So this part here is du by dt. Okay, so again, what's the derivative of cosine u? Negative sine u times the derivative of u itself. So it's 5 minus all of this multiplied together. So let's work this out. So it's a negative 50 multiplied by a negative 1 and by a 120 pi. All of that will be the constant, so it'll be a positive number. So I need to know what, I guess, 50 times 120 is. 5 times 12, I guess, is 60. So 6,000 pi, I believe, is correct. And then a cosine function and a sine function. Cosine 120 pi t, sine 120 pi t, like that. Okay? So in simplifying, so the first term stays 5. In simplifying the second term, I multiplied negative 50 by negative 1 by 120 pi. And I got positive 6,000 pi as the constant, and that is preceding the multiplication of the two trigonometric functions. Okay, so yeah, chain rule, composition of functions. We did a quotient, a product, chain rule, and this was just a very typical sine cos u, the derivative of cos u, number 1. No fancy rules there, but okay, I know this isn't terribly easy, but when you get the hang of it, so if you understand this lesson well, all the other lessons will be the same, okay? So the next time we have a lesson, we're going to concentrate on the next 4 here, the remaining trigonometric functions. Then we'll have one on the natural logarithm, another one on the exponential function. So 1, 2, 3 more. You'll find that, you know, a good understanding of this will definitely help you with those videos that follow. So please take the time. This is 27.1 is the chapter reference. There are some examples in your textbook. You can start with, I would say, start with example 2 is good, example 3. If you like reading the examples in the textbook, you can go through those. Yeah, example 4 looks good. Example 5, example 6. So there are some additional examples you can read through there. Example 7 as well. Those are all great examples. And then I have recommended some questions from the exercise for you to try as well. Okay? All right. Thanks so much. Have a good day.